Hey everybody, it's Miss Hunt. I'm going to try to see if I can get my document camera up and running. That is not what I wanted. Okay, let me try it again. Yay! Okay. For all my quarantine kids, I'm so sorry you're not with us. And I can't wait to have you back in my class. Okay, so today we are learning about dihybrid. So yesterday we began this beautiful genetics packet. And let me also just say that if you learn everything in this packet, you have mastered genetics. So yesterday we ran through the first page, and all these I've taken pictures of, and I've put them on the Google Classroom. So you can be able to go back and look at them and check your work as you go through. Remember, we're heavy on vocabulary, so make sure you're paying attention to your vocab terms. Okay. We did the backside here yesterday. Let me zoom out real quick. Okay. Okay. And then we did this side on yesterday, and some of the kids got finished, some of them didn't. We had to, first period, we picked up here and we finished these up, but I think I took pictures of them and put them on the Google Classroom for you. So this is pretty much the basic stuff. A lot of the kids had questions about number 13, if 13 pertained to 12 or not. I don't know, it doesn't say. So I just chose to say dominant trait. If you said that it was pertaining to number 12 and it was tongue rolling, then you could have had 75% tongue rolling and 25% not tongue rolling. Okay, so today we're going to get into the dihybrids, okay? And let's learn about these. So I'm going to zoom in a little bit more here. There we go. Okay, so first of all, let's talk about this word dihybrid. So far, we've done monohybrids, where it's one trait, like height, and you had genotypes of like big T, little t. With a dihybrid, we have two traits. So we're going to see in dihybrid like a big T, little t, and a big B, little b. So we're going to see both on here. So we have 4 letters instead of the 2 letters for a dihybrid. Right? And this kind of gives us more of a realistic approach to what real genotypes are. In the classroom the other day, we talked about eye color. And eye color isn't really brown or blue. It's not a dominant recessive. It's multiple alleles. There's lots of different things that go into your eye color, including melanin, which melanin is the color in our whole body. Melanin gives us our hair color, our skin color, and our eye color. So we often see people who are really fair skin with light color hair and blue eyes. And we see kids with darker skin, with darker eyes and darker hair. So that melanin is there. So it gives us more of a realistic thing. I often use hair as an example. My hair comes in a color, brown, black, blonde, red, but it also comes in a texture, straight, curly, wavy. So when I inherit hair, I'm going to get a color and a texture. So kind of think about it like that. So you could be a brown wavy or a black straight or a red curly. There's lots of different phenotypes and genotypes that you could inherit. Okay, so let's go back to our story here and let's read for information. Remember, underlining is really important as you read these. All right, in guinea pigs, short hair is dominant. So I've underlined short hair is dominant to long hair. And I go ahead and put a capital S for short hair because that reminds me that this is going to get a capital S for me. And black eyes are dominant to red. So I went ahead and put a capital B for black eyes are dominant to red. Those will get a little b. A male guinea pig that is homozygous dominant for both traits. So if you're homozygous dominant for both traits, So you're going to have big S, big B, homozygous dominant for both traits, is crossed with a female who has long hair. Long hair was my recessive, and red eyes is also my recessive. So I've got little s, little b. So notice I've got 4 letters in my cross, okay? Now when it comes time to set these up, these are my gametes. So if I think about this is the male, what is he going to put inside of each of his sperm? Remember, every sperm has to get an S and every sperm has to get a B, but what is he going to put in each one? Well, all of his letters are the same. So he only has big S and big B to give. And the same thing here in the egg. Every egg is going to get an S and every egg is going to get a B, but they're all the same. So every S and little b. So we're putting these on the line. So I got that from looking up here. Big S, big B, big S, big B. And now I'm putting these possible gametes on my Punnett square here. I'll take these recessive ones and I'll put them on the side here. Okay. Now, every square is going to have 4 letters. And keep your letters together. So keep your S's together and keep your B's together. Okay. Now, I could fill out this whole thing, but it is all the same answer. This one's not a very interesting question here, but maybe it's easy, so that's great. All right. This one is 100% heterozygous for both traits. And the phenotype will be 100% short, because everybody got a capital S, hair, and black eyes, because everybody got a capital B. Okay? Now, the real fun is doing a heterozygous. So we've answered this one. But if a parent was heterozygous, if your parent's heterozygous for both traits, then you have lots of possible gametes. I recommend doing the FOIL method. You do FOIL in math. So when you do factoring, you do the first. So the first would be the big S and big B gamete. So that's what I put there. Outside, so the big S and little b gamete. There you go. Inside, little s and big B. And last, little s and little b. Okay. Foiling just makes sure that I've got all the possible gametes that could come from these two, from this parent, from those traits. So it just makes me make sure that I've got them all. And that's a more fun one to do. Okay. All right, let me walk you through number 2 so I can help you with this one too. Okay, in fruit flies, the allele for normal size wings, capital H, is dominant. So they've given an H for normal wings, and vestigial wings are little h. This is actually a real Punnett square, real traits for fruit flies. Vestigial wings end up in like a really short little wing that they can't fly. It's all sad, but it is a mutant wing. So it is a recessive, so little h and big H, okay? And eye size, normal eye size is capital E, is dominant over an allele for small eyes, little e. So the gene for wing and eye size are on different chromosomes. Predict the result of a cross between a heterozygous individual for both traits, and an individual who's homozygous recessive for both traits. All right, I've done this on paper and I've done it in blue ink, so I'm really hoping that that shows up. Okay, I think we can see that pretty good. Okay. There we go. Okay, so here's my heterozygous for both traits, a big H, little h, big E, little e. And I'm crossing it with a homozygous recessive for both traits, little h, little e, little e. Now this one will require me to figure out these possible gametes, making sure everybody inherits an H and everybody inherits an E. I did the FOIL method, so I did the first, big H, big E, right there. Okay, outside, big H, little e. Inside, little h, big E. And last, little h, little e. There we go. Now on my homozygous recessive, there's only little h and little e. So I put him down the side. Of course, I could finish filling in this Punnett square, but all of these will have the same answers in the whole column. Okay? And remember, as much as we love beautiful Punnett squares, this doesn't give me a grade. This is where the answer is down here. Okay? So the next thing is looking at my genotypes. Of my genotypes, I have to remember that there are 16 possibilities, but because this one is basically 1/4, 1/4, 1/4, and 1/4. So 25% mine will be heterozygous for both traits. 25% will be heterozygous and homozygous recessive. 25% will be homozygous recessive and heterozygous. And 25% will be homozygous recessive for both. For my phenotypes, and that matches my genotypes up here, we will have 25% normal eye, normal wing, 25% normal wing, small eye, 25% vestigial wing, normal eye, and then 25% vestigial wing and red eyes for my recessive traits. Okay? All right. That's at least how to do it. So I hope that that helps you guys out. I will be posting pictures of these and the answers later today so that you guys can check back. If you finish this side, I'll be very happy. Okay, so if you can work on these. And remember down here, this is when we're going to get in that different little ratio based on the numbers we have. So you're looking at the numbers. And so here, this is our parent, but we want to know what the F2 generation is. So if this is the parent, when they cross, they all will be heterozygous. So this, my F2, will be crossing two heterozygous traits. So that'll be more interesting and give me a better ratio down here. And it's good if they want phenotype. Giving genotype is a little bit more tricky. I don't know what's happening with my camera. Okay. Genotypes are a little bit more tricky. Okay. Well, I'm done anyway. So let me know if you have any questions or you need any more help. Thanks. Have a great day.